Hello everyone, in this video I'll be discussing about class fundamentals in Java. Introduction to classes in Java. Classes are the blueprint for creating objects in Java and they encapsulate data and behavior into a single unit. The objects are instances of classes. Here, the processor will be divided into class, data members, methods. In class, computer, in data members, version number, storage capacity, etc. And defining a class. A class keyword followed by the class name to define a class and define class variables and methods within the class. Classes can also have constructor for initializing objects. Class members. Class variables are also known as fields and represent the data for each object. Methods define the behavior of the class and can manipulate the class data. A class can also have constructors and static members. Access modifiers. Access modifiers control the visibility and accessibility for class members. Public. Members are accessible from any class. Private members are only accessible within the class. Access modifiers in Java. Access modifiers public, protected, default, and private. These can be accessed within the class, other than class, in subclasses, and any classes. Creating objects. Use the new keyword followed by the class name to create an object. Objects can access the class variables and methods. Each object has its own set of instance variables. Constructors. Constructors are specially methods used to initialize the objects. Default constructors are provided if no constructor is defined. Constructors can be overloaded to accept the different parameters. Inheritance. Inheritance allows a class to inherit fields and methods from the another class. The extends keyword is used to establish a subclass relationship. Java supports single inheritance where a class can only inherit from one superclass. In inheritance, there are multiple types such as single inheritance, hybrid inheritance, multi-level inheritance, and multiple inheritance, and also hierarchy level inheritance. You can observe the diagrams given in the picture. Polymorphism. Polymorphism allows objects of different classes to be treated as objects of a common superclass. Method overloading and overriding are common examples of polymorphism. Polymorphism increases flexibility and reusability in code. Encapsulation. Encapsulation is the practice of hiding internal implementation details and exposing only necessary information. Encapsulation is achieved by using private access modifiers and getter or setter methods. It helps in achieving data hiding and code maintainability. Abstraction. Abstraction focuses on the essential features of an object while hiding an unnecessary details. The essential characteristics of abstraction are crisply defined conceptual boundaries, kinds of objects, and perspective of the user. Abstract classes and interfaces are used to achieve abstraction. Abstraction simplifies complex systems by providing a clear separation of concerns. Then, class methods. Static methods belong to the class itself and can be called without creating an object. Instance methods are associated with objects and can access instant variables. Methods can have return type and parameters. Method overloading. Method overloading allows a class to have multiple methods with the same name but with different parameters. The compiler determines which method to call based on the number and type of arguments. Method overloading is a form of compile time polymorphism. You can observe the example of function overloading here. Method overriding. Method overriding allows a subclass to provide a specific implementation of a method that is already defined in its superclass. The overridden method must have the same signature as the superclass method. Method overriding is a form of runtime polymorphism. The difference between overriding and overloading are as follows. In overriding, runtime polymorphism, overloading, compile time polymorphism, occurs between two classes using inheritance, but it occurs within the class. Array elements are stored in the contiguous locations, making it easy to determine relative locations of elements. Insertion and deletion operations are slow as elements are supposed to be stored sequentially index wise. Class design best practices. Follow naming conventions for classes, variables, and methods. Use access modifiers appropriately to control visibility. Keep classes focused on the single responsibility to promote code reusability and maintainability. Overall conclusion will be understanding class fundamentals is essential for object-oriented programming in Java, and classes provide a blueprint for creating objects and encapsulation data and behavior. By following best practices and principles, developers can create well-designed and maintainable Java applications.